Hi everyone! Welcome to STEM class. In the last lesson, we learned what tolerance means and how a whole plate works. Today, let's build a bridge together. Have you ever seen a bridge that really impressed you? In our daily life, we can see many different kinds of bridges. Some bridges are very big and can cross valleys, lakes, and seas. Some bridges are small and help us cross streams and rivers. Do you know how bridges have changed through history? Bridges have a very long history. A long time ago, some trees were blown down by the wind and happened to fall across small rivers. This became one of the earliest kinds of bridges, the log bridge. It could not hold to much weight, but it was enough for small animals or people to walk across. Later, people began to use more materials to build bridges. Wood, ropes, and stones were slowly used in bridge building. Bridges became stronger and steadier. Today, with steel and concrete, bridges can be taller, longer, and much stronger. Among many bridge designs, the arch bridge is very special. About 1,400 years ago, China built the famous bridge. It is a classic stone arch bridge. Its clever shape helps spread the weight to both sides. From ancient times until now, every bridge design shows human wisdom. It's time for our load-bearing challenge. Let's see how much weight different bridge structures can hold. In this lesson, we will print one bridge frame, one road deck, and 6 small cars. If you like, you can print more cars too. Now, let's start printing together. First, find the models we need for this lesson and print them in order. Please remember, the bridge deck is very thin, so turn off the raft before printing. Look, the 3D printer is starting. Printing takes some time, so please wait patiently. Let's take a short break. Great job! The parts are printed. Let's try them together. First, place the bridge frame on the table. Then put the bridge deck flat on top. Gently place small cars on the bridge deck and slowly add more. Let's see how much weight it can hold. Wow! We can see that a flat bridge deck can only hold a limited amount of weight. Next, let's upgrade our bridge. Prepare 3 rectangular paper strips in the length shown in the video. Gently bend the paper into an arch shape and place it under the bridge deck. Place the small cars on the bridge deck slowly. Great! After adding the arch support, the bridge deck is clearly steadier. Next, let's try a bridge with 2 arch supports. Use the slightly smaller paper strips and gently place them under the bridge deck. The challenge begins. In our experiment, The double arch structure seems stronger and more reliable. Why does the bridge deck become stronger after we add arch supports under it? Because an arch is like a little helper. It can spread the weight from heavy objects to both sides. So one spot does not take too much weight. This makes the bridge deck steadier and less likely to collapse. In this lesson, we learned how bridges changed step by step. We also used an arch bridge to complete a small load-bearing experiment. 3D printing, your great learning partner. Keep exploring, and see you next class.